This is John from the LA office, and today I want to talk about rebar caps. Pretty much every project has impalement hazards, which we mitigate with these caps, and once they're in place, they do provide adequate protection against the hazard. The problem with the caps is the maintenance of them. How many times do you go past an area where you've just put rebar caps on, only to find a whole bunch have already been knocked off? How about the times you have to go back and reinstall rebar caps for the long-term exposed owls, like these ones for the mason who won't mobilize on this floor for many months? What about the decorative rebar caps? You know the ones I'm talking about. The ones that you put on rebar that's coming out horizontally out of a slab that you know have little to any chance of staying on. Ever had dowels hang down from the structure above? Traditional rebar caps offer little to any protection for that. Okay, besides the fact that a lot of these rebar caps that get knocked off either end up being damaged or end up in a trash pile, and the cost of having to go back and always put these things back on really adds up. Bottom line is, when these caps are missing, the exposure to the impalement hazard is still there. So, what if you had a rebar cap that the more force you put on it, the tighter it grabs? Something that doesn't damage the rebar, leave residue, still easy to put on, it won't let go for the life of it until you want it to. So, how does it work? Do any of you as a kid remember playing with one of these? I think they were called Chinese Lover Link or something when I was a kid. But basically, it's a woven piece of nylon that the tighter you pull, the tighter it grabs on your finger, and the only way to get it off is to put it into compression, and then it slides right off. Well, this works the same way. So, first let me start off by going over the rebar cap itself. Okay, so the rebar cap, the structural part is this part up here. There's actually a piece of steel that gets cast into the mold as part of this design. Then you have the shaft, which is basically the guide for the rebar as it goes in. And it's got a couple fins in there, although those tend to wear out pretty quick and aren't really long-term effective. So we started off by making a hole into the side of the guide for the rebar cap, not anything through the structural part. And we took a piece of woven nylon, one end of which goes onto the rebar. Then from there, it goes through the rebar cap, then comes out the other end and goes through itself in this part, creating double compression capability. So when you pull on this grabs tighter onto the rebar. When the rope gets put on tension, it grabs itself where it goes through here. So you put the rebar in, you tighten the string up, and boom, you're done. It's not going anywhere. Yet put it into compression, and it comes right off. Now I know the safety people are gonna say, you've made a hole through the side of an engineered and tested safety device, and it has not been tested with that hole in it to see whether or not it still meets the OSHA requirements for the testing. And that is correct. However, what if we could get it tested?